Okay, hi everybody. So we're going to be looking at Kirchhoff's second rule, the loop rule, and this is based upon the conservation of energy, where all of the sums of electric potential that increase around the loop plus all the decreases have to equal zero. And there's a couple of rules you have to apply in order to figure these kinds of questions out. You'll know you have to use the loop rule mostly if you see multiple batteries in a circuit, and that's like one giveaway that we're looking at the loop rule because we've never seen more than one battery in a circuit before. So here are some of the rules. If they're not already marked, mark the positive and negative terminals of the battery. Remember, the long end is the positive end and the short end is the negative end. Okay, so mark those on your drawing. You're going to choose a direction for the current if it's not stated. So this is an assumption. So assume the direction. Okay, this is to be checked later on, and it goes over in letter D to check whether your assumed direction is correct or not. All right, so you're just going to pick a random point around the circuit, and you're going to account for all the changes in potential. So the rules are, if you go from the positive side to the negative side of battery, then you have a negative change in potential. This symbol, the E over here, this just represents EMF. That's ideal voltage that you would see if you had no losses of energy through a battery. And all batteries have a little bit of a loss of energy. So when you see EMF, that just is saying ideal voltage without any losses. Okay, so positive to negative, it's negative. Negative to positive, you have a positive change in EMF. Okay, any resistor or device is going to be a negative change. Okay, and then you set the sum of all the potential changes equal to 0, and then you solve for I. If I is negative, then you assume the wrong direction, so you just have to flip the direction of the current. So it's a lot easier to do this if you actually apply it in a problem rather than just talking about it. But let's just pick a random point in this circuit. You'll see that the batteries actually have positives and negatives on that already, so we don't have to worry. So this is just our assumed point, and let's just say we're going to go clockwise around this circuit. So we have to find that current that's passing through all these devices. So remember the rules. We have a resistor, so that's going to be a negative V. Okay, we're going from positive to negative, so that's another negative V. Here's another resistor, so that's going to be a negative V. We're following the current around. Now we're going from negative to positive on a battery, so that's a positive V. And then we have another resistor, so that's going to be a negative V. Okay, so I may zoom out a little so we can see the picture and what I'm writing at the same time. So this is the next part where you have to sum the voltages around the circuit, and they have to equal 0 according to the loop rule. So based on where we started, we're going to have this 5 ohm resistor. But how do you turn resistance into voltage, which is what we're adding up here? And you should remember, well, that's simple. We're just going to use I times R. So I'm not going to really write an original equation for this, but I will, we'll have I as our variable. So we're going to have I times 5 ohms. And remember, we have to make this negative. So I'm going to sneak a negative in here somewhere. All right, we have negative I times 5 ohms, and then we have minus 6 volts, because that's already in volts. And then we have minus I times 6 ohms. And then we're going to have plus 9 volts. And then finally minus I times 4 ohms. Okay, so you just treat I as your variable because it is. And we're just going to add all those up. So negative 5 plus negative 6 plus negative 4. So we're going to have negative, what was that again? 11, 15. Negative 15 ohms times I. I'll just switch that around. And then we have negative 6 plus positive 9. So we're going to have positive 3 volts. equals 0. I have to solve out for I here, so I'm going to bring the negative 15 I to the other side, so 15 ohms times I, and we're going to solve out. All right, so 3 over 15, so that's going to be 1/5, and that is I, and if we did our math correctly, that actually came out positive. So if it came out positive, that means the assumed direction, the clockwise direction of my current was assumed correctly, and I don't need to switch the direction of my current. Okay, so that was, a simple first part of this problem. And once you find the correct direction of your current, you have to follow it. And now we can actually use that magnitude of that current to solve the rest of the problems. So now it says determine the potential difference from point A to point B. And to do that, you have to follow the actual direction of the current, not the assumed direction. But we just happen to assume the right direction, so we don't have to worry about flipping what we were thinking. So from A to B, the current from A to B, just look at what I would pass over going from A to B in the clockwise direction. Now, if you, for argument's sake, said you assumed counterclockwise and you forgot to flip it, look at the other devices you would cross over if you followed the wrong direction of current. So it's important that you read the question and make sure you're following the actual direction of current after you establish what it is. All right, so you're going to do the same thing. You're going to sum the potential over the devices, but we're not making a complete loop. So it's not going to equal 0 like in part A. We're just going to go over the devices and follow the rules that we learned on the previous page. So we still have one resistor with a negative potential, so it's going to be negative. Our current is 1/5 or 0.2 amps times 5. Okay, and then we're going to go from positive to negative on the battery, so that's going to be another negative voltage drop. And we're going to get total voltage. And writing from points A to B, it's going to be negative 7V. Okay? All right, and then the final thing, determine the voltage drop over the 4 ohm resistor. So this is just a simple Ohm's law calculation. V equals I times R. And you could account for the fact that all resistors are going to be negative, so we're going to have 0.2 amps times negative 4 ohms, and you're going to get negative 0.8 volts. Okay, so problem number 2, you'll see the batteries are not labeled anywhere, so I'm going to go through and just label them all positive, negative, based on the terminals of their battery. All right, and now we have to pick an arbitrary point. I'll pick this corner, and I'll continue with I'm going to assume a clockwise current. Okay, we have to check back later and make sure that's correct. So remember, positive to negative on a battery is a negative potential drop. A resistor is a negative potential drop. Negative to positive is positive. Okay, so just go around and label them all. Here we're going from negative to positive, so that's positive. Positive to negative is negative, and then we have negative. Okay, so based on our assumed direction of the current, I'm going to determine the magnitude and direction of the current using the loop rule. So the sum of the potentials around the loop, we have to make one complete loop around the circle. Circle, circuit, same thing. Not really. The sum of the potentials has to equal 0. So starting up at that upper left-hand corner, I'm going to first have a negative 12 volt potential drop. And then I'm going to have minus I, which is unknown, times 20 ohms. And then I'm going to have a positive potential of 9 volts, followed by a negative potential of 6 volts. And then I'm going to have another negative, I'm going to have to go to the next line, negative I times 30 ohms, and then negative to positive, so we're going to have plus 3 volts, and then minus I times 15 minus 4.5, and almost there. I need a little bit more room. Okay, and then minus I times 22 ohms. Okay, so you're going to combine all like terms. So we're going to add up all the resistances. So negative 20 plus negative 30 plus negative 15 plus negative 22. So we're going to get negative I 87 ohms. Okay, and then we're going to have negative 12 plus positive 9 minus 6 plus 3 minus 4.5. So we get negative 10.5 volts equals 0. So you notice both of these are negative right now. So even when I move the 10.5 to the other side of the equation, divide by 87, I get negative 0.12 amps. So the negative sign here means that we assumed the wrong direction. And there's nothing major that you have to do except that you need to report your answer with the same magnitude, but just say counterclockwise. And for the rest of the problem, you have to follow this counterclockwise direction, otherwise you'll be getting them wrong. All right, so now I go back to my picture so I don't mess anything up. I'm gonna no longer assume, I'm gonna know that current flows counterclockwise around the circle or circuit. It's not a circle. All right, part B, it says determine the potential difference between points A and point B. And this is why it's important to follow the actual current, because I could go A to B this way, but that would be going in a clockwise direction, and I would pass over completely different devices than if I actually did what the question's asking me to do, which is go from A to B following the direction of current. Okay, so A to B, we would go that way. Right, so we're not doing a complete loop, so we're not adding all the potentials to 0. We are just doing half of a loop. So I'm just going to write, I'm going to sum the potentials around the circuit, and you follow Kirchhoff's rule about positives and negatives again. So some of these, let's see, positive to negative, yeah, all of these that I marked before, they don't apply in this scenario, so we got to be careful and realize, all right, positive to negative on a battery, that's negative V. This will be a resistor negative V, negative to positive, positive V, negative V, and then positive V again. So don't go by what you wrote there before because you assume the wrong direction. All right, so following A to B, we have a negative potential of 9 volts, followed by negative, what's the current again? 0.12 amps times 20 ohms, plus 12 volts. Okay, and then we're going to do minus 0.12 amps times 22 ohms plus 4.5 volts. Okay, so just add all those up in your calculator. Okay, so we should get a potential from points A to B of 2.46 volts, and that came out positive. Okay, so I think that's the last one I'm going to do today. All the answers should be up in a separate file on Canvas if you want to check anything from the packet. And we're pretty much done with the circuit notes. Tomorrow, after you try, all these problems and make sure you got them all, you'll be working on a parallel lab, and we'll try to do it on PhET, and you'll have to do the simulation yourself and take some data. Okay? Thanks for listening.